Hello students, welcome back again to the mathematics class of class 6. Today I will explain you the divisibility rules. What are divisibility rules, students? A rule to find whether a given number is divisible by another number without performing division. So students, first of all, the divisibility rule of 2. What does it say, students? If any number having the even number at its units place will be divisible by 2. So, is it divisible by 2? No. Why? Because the digit at the unit place is 3, which is not an even number. And here in 14 it is divisible by 2 because the number at the unit place is even, that is 4. It is also divisible by 2 because the number at the unit place is even, which is 2. The digit at the unit place in 16 is 6, which is divisible by 2. But the unit place in the 21 is 1, which is not an even number. So this 21 will not be divisible by 2. The second rule, divisibility rule of 3. Divisibility rule of 3 says, students, any number is divisible by 3 only and only if the sum of the digits is divisible by 3. What do you mean by this, students? Let's take one example. Suppose 135. A number is 135. What you have to do? You have to find the sum of all the digits. What it will be? 5 plus 3 plus 1. That is 9. Now the sum of all the digits is 9. Now you have to check either 9 is divisible by 3 or not, which is the sum of all the digits. So 9 is divisible by 3. 3 3 ja 9. So you can say that 135 is divisible by 3. Let's take one more example, students. 20652. Now what you have to do? You have to find the sum of all the digits, which is 2 plus 0 plus 6 plus 5 plus 2. 2 plus 6 is 8. Plus 5 is 13 and 2 is 15. Now you have to check either 15, that is the sum of all the digits, is divisible by 3 or not. So 15 is divisible by 3 because 3 5 are 15. Therefore this 20,652 is divisible by 3. Now divisibility rule of 4. What is it, students? A number is divisible by 4 only and only when the number formed by taking the digits at tens place and unit place is divisible by 4. See one example. 2, 3, 4, 2. So what is the rule, students? The number formed by taking the digits at 1 and tens place is 42. Now you have to check, is this number divisible by 4 or not? No, it is not divisible, not exactly divisible by 4. So this number is not divisible by 4. Let's take another example, students. So according to our divisibility rule of 4, the number formed by taking the digits at tens and ones place is 24. So 24 is divisible by 4. Yes, 4 5 are 20, 4 6 are 24. So 2324 is also divisible by 4. Next is divisibility rule of 5. A number is divisible by 5 only and only when the unit digit is 0 or 5. See, students, any number 2035, is it divisible by 5? Yes, because the unit digit number is 5. 20360. This is also divisible by 5 because the unit digit number is 0. Is this number divisible by 5? No, because the digit at the unit place is 7. So, the digit at the unit place must be 0 or 5 if it is divisible by 5. Let's take another example. 5670. Let's check this number either it is divisible by 6 or not. So, this is divisible by 2. Let's check either this number is divisible by 3 or not. 5 plus 6 is 11 and 11 plus 7 is 18 and 18 is divisible by 3. So, this number is also divisible by 3. So, if this number is divisible by both the numbers, that is by 2 and 3, then it is divisible by 6 also, because our divisibility rule of 6 says that a number must be divisible by 6 only and only when it is divisible by both 2 and 3. Now students, divisibility rule of 7. The divisibility rule of 7 says that double the last digit number, that is unit digit number, and subtract the number from 74, that is from rest of the number, and then find either the difference is divisible by 7 or not. If the difference or the resulting number is divisible by 7, then the original number will be divisible by 7. See, what you have to do, students? You have to double the unit digit number, and the double of 9 is 18. That means you have to multiply it by 2, the unit digit number. And then you have to subtract the number from rest of the number. What is the rest of the number? 74. You have to subtract the double of the unit digit number from the rest of the number. Now, you will get 14 minus 8 is 6 and 6 minus 1 is 56. Now, you have to check either this number is divisible by 7 or not. Yes, 7 8 ja 56. 56 is divisible by 7. Then the whole number, that is 749, is divisible by 7. Now, the divisibility rule of 8. What is this, students? A number is divisible by 8 only and only when the number formed by the digits at 100, tens and ones place is divisible by 8. So, number formed by these 3 digits, students, is 152. You have to check either this number is divisible by 8 or not. 8 1 ja 8. 15 minus 8 is 7. 8 9 ja 72. So, the number formed by the digits at 100 tens place is 152 and is divisible by 8. So, you can say the whole number, that is 67152, is divisible by 8. Divisibility rule of 9. What is it, students? If the sum of the digits is divisible by 9, then the original number will be divisible by 9. It is the same as the divisibility rule of 3. Take one example. 3, 1, 2, 6, 3, 7, 4. Suppose I have taken a big number. Now you have to add all the digits. 1 plus 2, 3 plus 1 plus 2 plus 6 plus 3 plus 7 plus 4. 3 plus 1 is 4, 5, 6, 12, 15, 19 and 26. The sum is 26 and which is not divisible by 9. So, this number will not be divisible by 9. Let's take another example. 7605. 7 plus 6 plus 0 plus 5 is 18 and 18 is divisible by 9. Therefore, 7605 is also divisible by 9. Divisibility rule of 10. Any number is divisible by 10 only and only when the unit digit will be 0. Suppose 3, 5, 6, 0. What is the digit at the unit place, students? It is 0. Then this number is divisible by 10. You have to check the unit digit number. It must be 0. If it is 0, then it is simply divisible by 10. Otherwise not. Now students, divisibility rule of 11. A number is divisible by 11 only when the difference of the sum of the digits at even place and the sum of the digits at odd place is either 0 or the multiple of 11. See how. Let's take one example. 3, 4, 5, 6, 7, 8. A number is there 3,45,678. So we will start writing from here 1, 2, 3, 4, 5, 6. We will give numbers to them in a sequence from right to left. So odd, even, odd, even, odd, even. We always start with odd because this 1 is odd, 2 is even, 3 is odd, 4 is even, 5 is odd, 6 is even. So the digits at even places are students 3, 5 and 7. So you will add 3 plus 5 plus 7, which is equals to students 15. And the digits at odd places are students are 4 plus 6 plus 8, which is equals to students 18. And what you have to do finally, you have to find the difference of the sum of the digits at odd places and the digits at even places. 8 minus 5, that is 18 minus 5 is 3, and 3 is neither 0 nor the multiple of 11. So this number is not divisible by 11. Let's take another example, student. 61,809. So what are the digits at even places and what are the digits at odd places? Odd, even, odd, even, odd. We will always start with odd because the first digit is 1, because we always start placing the digits from 1, 2 and 1 is an odd number. So the sum of the digits at odd places is 6 plus 8 plus 9 and the digits at the even places are 1 plus 0 is equals to 1. 8, 8, 16, 17, 18, 19, 20, it is 23. And the difference 23 minus 1 is equals to 22. And what is 22, students? It is the multiple of 11 because 11 to the 22. Now you can say that 61,809 is divisible by 11. Now students, properties of divisibility. The first property is, students, if a number is divisible by any other number, then that number must be divisible by the factors of that number. See how. Suppose 36 is divisible by 12. So 36 will be divisible by the factors of 12 also, students. You can say 1, 2, 3. These are the factors of 12. 4, 6 and 12. So if 36 is divisible by 12, then 36 must be divisible by 1, 2, 3, 4, 6 and 12 because these are the factors of 12. Now the next property is, students, if any number is divisible by more than 2 co-prime numbers, then it will be divisible by the product of those 2 co-prime numbers. See how, students, if we take one example, students, 378. 378. It is divisible by, students, 3. 3 1 are 3. 3 2 are 6. 3 6 are 18. Yes, it is divisible by 3 because by dividing it by 3 we get this. It is also divisible by 7, students. 7 5 are 35. 7 4 are 28. So it is divisible by 7. And both these numbers are co-prime. What the co-prime definition is? The definition of co-prime is this, that two numbers are said to be co-prime if the common factors between them is 1 only, students. And the factors of 3 is 1 and 3, and the factors of 7 are 7 and 1, and the common factor is 1 only. So both the numbers are co-prime, and this 378 is divisible by both the co-prime numbers, that is by 3 and 7, by the pair of co-prime numbers. So it will be divisible by the product of these two co-prime numbers, that is by 21. So 378 must be divisible by 21, which is the product of the co-prime numbers. Third property, students, that if any number is the factor of each of the two given number, then that number must be the factor of the sum of that two numbers. See how, students, suppose 5 is the factor of, students, suppose 15, and 5 is also the factor of, students, 25 or 20. So 5 is the factor of 15 and 25 also. So you can say that 2, 1, 3 and 1 carry 40. Then 5 will be the factor of the sum of the two numbers, that is of 40. Isn't it? Similarly, students, there is one more property, that if the given number, or you can say if any number is the factor of each of the two given numbers, then it must be the factor of the difference of these two given numbers. That means if 5 is the factor of 15 and 5 is again the factor of 25, and the difference of 25 and 15 is 10, then 5 must be the factor of 10 also. Now let's do the questions from the learning check 3.4. Question number 5 is this, students. A blank has been given to you. You have to write a single digit number here. That means you have to write that smallest digit number. By writing that smallest digit number, the new number must be divisible by 3. So students, suppose here is a number x. So x plus 6 plus 7 plus 2 plus 4 is equals to x plus 6 plus 4 is 10, 17, 18, 19. And students, just read out the table of 3. 3 5 are 15, 3 6 are 18 and 3 7 are 21. So we have written 3 6 are 18 and 3 7 are 21. So, and the sum is here 19, and 21 minus 19 is, students, 2. So if we write 2 in place of x, so what you will get, 2 plus 19 is equals to 21, because the next multiple of 3 is 21 after 19. Just in order to make it 21, we have added 2 here. Similarly, students, in question number 6, you have to write a single digit number to make this number divisible by 9. So students, the divisibility rule of 9 says, suppose here is a number x, so 4 plus 8 plus 7 plus x plus 6 will be what, students? 6 plus 4 is 10, 10 plus 8 is 18, 18 plus 7 is 25 plus x. Now read out the table of 9. 9 1 ja 9, 9 2 ja 18, 9 3 ja 27, and 25 is in between 18 and 27. 25 is in between 18 and 27. So the next multiple after 18 is 27. So we will, and 27 minus 25 is 2. So we can again write 2 in place of x. You can write 2 here. See question number 7, students. By which number you can replace this box to make the resulting number divisible by 11? And the divisibility rule of 11 says that the difference between the sum of the digits at odd place and sum of the digits at even place must be 0 or the multiple of 11. So we can write odd, even, odd, even, odd. So suppose x is there, find the sum of the digits at odd places, which is 7 plus x plus 2, and the sum of the digits at even places is 9 plus 6, which is equals to, students, 9 plus x, and which is equals to 15. Now you have to find the difference of these two. That means this and this. Difference is, students, 9 plus x minus 15 is, students, 15 minus 9 is 6, that is minus 6 plus x. So students, we can easily find that if we will replace x by plus 6, then the resulting number will be 0. Doing so, students, minus 6 plus 6 will give you 0. So here the value of x will be 6. So the resulting number will be 7662, and which is exactly divisible by 11. As the word prime is written there before factorization, that means prime factors. So students, what is a prime number? A number having two factors only. So you will divide 24 by the prime numbers only. 2 1 ja 2, 2 2 ja 4, again by 2, 2 6 ja 12, again by 2, 2 3 ja 6, again by 3, 1 ja 3. And you have to write these prime factors like this in the product form, students, in the multiplication form, students, that is 2 into 2 into 2 into 3. So these are the prime factors of the number 24. Next is, students, factor tree. Factor tree actually, students, is a structure to find the prime factors of any given number. Suppose take an example of 24. Make a tree structure like this, students, and write the prime factors of 24. 2, 12 ja 24, you will circle the prime factors only and will again make a tree structure, a structure like tree, students, like again you will write 2 6 ja 12 and will circle the prime number like this, students. Again this is, students, divisible by 2 prime numbers, 2 3 ja 6. So what are the prime factors? 2 2 2 3. The numbers which are in the circle, these are the prime factors of the number 24. With the help of factor tree structure, you can also write the prime factors of any given number. Now students, let's do some questions from the learning check 3.5. The first question is, students, you have to find the prime factors or if prime factorization product representation of 84. The number is given to you 84. You have to write this number in prime factorization method. Or you have to find the prime factors. You can say 2 4 ja 8, 2 2 ja 4, 2 2 ja 4, 2 1 ja 2, 3 7 ja 21 and 7 1 ja 7. Now 84 is equals to 2 into 2 into 3 into 7 into 1. So these are the prime factors of. See students, question number 3 is, students, write the smallest 5-digit number and express it in the prime factors. The smallest 5-digit number is, students, 10000, that is 10,000. And you have to express this number in the prime factors. So 2 5 ja 10, 2 2 ja 4, 2 5 ja 10, Again 2 1 the 2, 2 2 the 4, 2 5 the 10, 2 6 the 12, 2 2 the 4, 2 5 the 10. Again it is divisible by 5, 5 in the 5, 5 to the 10, 5 5 the 25, 5 to the 10, 5 5 the 25 and 5 5 the 25. Now it is 1 2 3 4, that is 2 into 2 into 2 into 2 into 5 into 5 into 5. Now students, in question number 6 you have to find the common factors of 15 and what has been given? 12. Common factors. That means you have to find all the factors of 15 and 12, not only the prime factors. So the factors of 15 are 1 and 15, 3, 5 the 15. That's all only students. So you can write it here. 5 and 15. And then another number is 12. That is 1 and 12. 2 6 the 12. And 3 and 4. Now students, you have to encircle the common factors, that is 1 and 3. So you can write common factors as 1 and 3. In question number 7 students, you have to find the common multiples of 2 and 4. You have to find the multiples. So the common multiples are students see 2 1 the 2, 2 2 the 4, 2 3 the 6, 2 4 the 8, 2 5 the 10, 2 6 the 12, 2 7 the 14 and so on. I have already told you that multiples are infinite and the factors are finite. That means you cannot count the multiples, but you can count the factors because the factors are limited. So you will always write dash 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 and 4 1 the 4, 4 2 the 8, 4 3 the 12, 4 4 the 16, 4 5 the 20, 4 6 the 24 and so on. Now encircle the common factors, that is 4, 8, here students it is 12, and so on. So the common multiples are 4, 8, 12 and so on.